Hey everyone, we're back.
And we are back with a brand new, fresh session from
My
a not so brand new speaker who actually talked yesterday.
yeah,
Yesterday, was it? Or day one?
it was
Um,
Yes.
day
yeah, day one. Then it was on day one.
one.
Mike
Yeah,
Geyser,
let's just bring him in.
yeah,
Let's
let's
just
bring
bring
him
him
to talk.
in. I can't wait. Hey Mike, so
Hey,
happy
I'm
to have you
back.
again.
Yes.
Yay!
so how are you
Thank you
doing
very
today?
much for having me
How are you
back.
doing
Yeah, I'm
today?
doing okay today. It's Friday. It'll be late Friday Mauritius time. So yeah,
That's okay,
looking
we are
forward
still
to
here for you.
Oh, yay!
Uh,
Absolutely.
So
Great.
last time you had the session about 11T,
Yes.
and this time it's Lighthouse, right? Diagnosing performance problems with Lighthouse. Um, you know what? Let's get you just started with the session, and we'll catch up with you with some Q&A at the end. All right?
Perfect. That's great by me.
All right. Have fun.
Awesome. Have fun. The
Thanks.
floor is yours.
Okay, awesome. So thank you everybody for having me back. I always enjoy speaking here, Mauritius, even if it's virtually. I'm Mike. I don't think you can see a picture of me on the screen at the moment, but you've just seen me previously, and I'll be back just now. I'm a Google developer expert in web technologies, and my specialization areas are in web performance and in capabilities, so installability and offline and that kind of thing. I am an organizer of the Josie.js meetup group, which has, because of the pandemic this year, gone completely online. So there's no excuse for you to not attend our meetups. Maybe there'll be something cool there that you can enjoy, or maybe you can catch up on some of the videos. Finally, I work at a company called TES, whose mission is, it's a company that believes in the power of great teaching and whose mission is to support and connect teachers and schools worldwide. And specifically what I do at TES is make sure that late on a Sunday afternoon, when teachers are frantically scrabbling for something to teach the next Monday morning, that the website is fast enough for them to get their stuff. So unsurprisingly, I am here to talk about performance. Now, performance is one of those things that's actually, it's really, really important, but never gets prioritized, right? We always either look at it way too late after we've done all the development work, or the cost of fixing our performance issues are usually too great. And it's not a skill that we typically hone. Now, that's not uncommon. We see that quite a lot. But I think that there is a compelling reason to convince people that performance is actually a feature and one of the most important features on web. So while I think you should care about performance as every developer, because firstly, like it can give you a real competitive advantage, and leading research indicates that there's this thing called just noticeable difference, which is that if you are 20% slower than your competition or 20% faster than your competition, it can significantly swing the way that people see you and whether they're going to engage and buy your product. Maybe you care about like organic growth of your web application, or new users or new user acquisition, in which case like it's important to know that performance is one of the most important things, second only to content itself, for search engine optimization and robots and trawling and that kind of thing. Or maybe like me, you care about the African context and building for emerging markets like ours, where connectivity is not always the best. And in that example, like performance is crucial when you're running on a mid-tier feature phone that has really limited CPU and RAM. And there are lots of design patterns specifically catering for low CPU devices. Or maybe you should just care about performance because you're a programmer. And maybe I can appeal to the programmer within you with one of my heroes and the legend that is Larry Wall, benevolent dictator of life for the Perl project. And that's where he talked about the 3 great virtues of a program. Laziness, which is the desire to do less work. Impatience, when the computer itself is being lazy, so you make programs that are very, very efficient to run and run quickly. And then hubris, where you don't want anyone to say anything bad about your code, so you write really, really good code. And I think that last one at the very least, and maybe the second last one as well, appeals to us as programmers. When we put our heart and soul into this thing that we're building, we want it to be really, really good. And some of that is the quality of the code itself, and some of that is the performance. So that's why you should care. Now, the star of the show itself is Lighthouse. But for a lot of you, I hear you asking, what is Lighthouse exactly? Like, why is this a thing that I should care about? Now, it is a bunch of things, but essentially it is evergreen developer tooling that's built into your browser, being Chrome, presuming you use Chrome, that accumulates a whole bunch of stuff, like best practice guidance, a whole bunch of really clear, concise, actionable audit responses with help documentation that backs it up, and very simple aggregated scores that socialize really detailed front-end performance metrics in a way that is consumable by people who are not necessarily so technical. You can take these scores to business, and they can also track and monitor this stuff and care about what they mean. And importantly, this is the runtime that runs a lot of the newer performance tooling that Google themselves uses, like PageSpeed Insights and Web.dev and a whole bunch of other stuff. Okay, so it's really a very useful tool. Now, when we get into what the score means, which is basically the starting point of engaging with Lighthouse, we have to understand a whole bunch of key metrics that it measures, right? We're going to go through those metrics in some detail, and those metrics are in this weighting where some of them count for more than others to give you sort of an aggregated score that doesn't really add up to 100, but it is supposed to make you feel like it is a simple out of 100 score to measure. Now, importantly, these numbers change over time. Now, were this movie, particularly probably set in the 90s, this is where we would cue the record scratch and the frame would freeze and I would stop talking and a narrator would voice over. Now, unfortunately, I don't have a narrator handy, so I'm going to have to do. These values change over time, which means that, in full disclosure, this was supposed to be a repeat of a talk that I did way earlier in this year, and all of this has changed subsequent to my talk earlier. And I've had to scramble in the last few days to make sure that I've got something that's at least interesting and engaging for you. And hopefully I've done that. But there's an opportunity for learning in any kind of disaster. So let's take a look at what we're learning. So the key metrics this year between Lighthouse 5 and 6 changed significantly. Not just the numbers, but also the metrics themselves. So they dropped 2 metrics and they added another 3. And we're going to go through them all in detail and explain the differences and why that's happened. Now, importantly, for future Mike and for anybody else watching this after the fact, these numbers will change over time. And the current set of metrics that we care about that make up the Lighthouse score are first contentful paint, speed index, largest contentful paint, time to interactive, total blocking time, and cumulative layout shift. Okay, so let's explain what some of these technical terms actually mean. Now, FCP, which is a common abbreviation for first contentful paint, is basically the time from when the page starts loading to when any part of the page's content is rendered onto the screen. And this is essentially a metric that's user-facing to show the perceived loading speed of when the site starts responding. Speed index is one of those weird metrics which shows the sort of progression of how quickly content is visually displayed during a page load. And it's kind of like a visual progression between frames. And you can think of it in analogous terms as a measure of frame rate, which those of you that come from or that play games or understand gaming parlance would appreciate. Then the first of the new metrics is largest contentful paint, commonly referred to as LCP. And this is how quickly the primary content of a web page loads and is visible to users. And now why this was particularly introduced is because simpler in context of measuring performance in a website is better. So this metric was not trying to figure out what is the most meaningful, but what is the biggest. So this is typically like your hero image or your main title or the body of text. Now, for the JavaScript developers amongst us, like me, time to interactive, TTI, is an essential one, which is the time from when the page starts loading to when its main sub-resources have loaded and it's capable of responding to user input, right? So the CPU is not busy anymore. And this is for when like the page loads and it looks like it's interactive, but nothing's clickable and it's janky and you can't scroll and that kind of thing. Now, another one of the new metrics, which is closely related to time to interactive, is something called total blocking time, or TBT. Now, this is a representation of long-running tasks in the browser front end. Because as we know, the browser's main thread only has a single process, a single thread. And everything happens on that one thread. So something that runs a long time and blocks that thread means that the browser page can't respond to user input, and no other JavaScript functions can be downloaded or queued or scheduled. And this is effectively the total amount of time that exists between the first contentful paint and time to interactive. Okay. One of the next new ones is called cumulative layout shift. And this is one that is actually kind of tricky to pin down, but it's essentially the unexpected movement of a page, either during or after page load. And commonly this results in like the user either misclicking or losing one's place when content loads. And you can imagine, you know what it's like as a page loads and things start subtly moving around, and that's less angering. But when you hover over a button and it suddenly shifts a little bit and you accidentally click on an ad, is a big deal. And this new metric is introduced for that. Now, let's just quickly cover the deprecated metrics as well, because I think they're useful to understand before we get into why they're deprecated. So first, meaningful paint was when the primary content of the page was visible to a user. And it was trying to figure out which was the first piece of content on the page. So it's not always so meaningful is difficult to find, but that was what it was doing, measuring how long until like an H1 was visible. Another one of the deprecated ones is, or the last of the deprecated ones, is first CPU idle, which was the amount of time it takes for the CPU to become minimally interactive, which is very closely related to time to interactive. And I think that's a good point for us to segue onto explaining why these were deprecated and why the changes existed and why there will be this continued flux of changes. So this particular change was firstly in the context of first meaningful paint, because first meaningful paint is sensitive to very small changes. So small changes on the markup, for example, could lead to wildly inconsistent and variable results, which meant that you had to deal with a whole bunch of flux in terms of the page, because identifying, or the performance score of a page when you're measuring it over time, because you have to identify what is in this moment the most meaningful bit, which is why they simplified and they went for first contentful paint and largest contentful paint. So the first thing rather than the first meaningful thing, and the largest thing painted onto the screen, because that's a little bit clearer to identify, which is the largest thing on the page. And then the second one, which is first CPU idle, is basically essentially the same as time to interactive. And from a development perspective on the Lighthouse team, there's a lot of overhead in tracking two similar metrics and scoring it. And realistically, there's a double whammy, because they were both similar. The two of them together added up to like 46% of the score, which meant that if you scored poorly in it, it hit you very heavily. And if you scored well in it, it artificially bloated your score to something really, really good, which we'll circle back to if we can. Now, in between those 2 points, Google also launched something that's sort of related, which is their idea of Web Vitals, the essential metrics for a healthy site. Now, we've discussed already largest contentful paint. And I missed one there. There was a copy-paste error. But that's supposed to be cumulative layout shift, so ignore that copy-paste error, apologies. So those two we've covered, and the one that we haven't is first input delay, which is how long from when the page loads to when the user can actually process input. They can type stuff onto the page or click on things. And now these are user-facing metrics. So first input delay doesn't actually exist in Lighthouse. When we talk about time to interactive, that's referring to first input delay. And I think one of the good things about this step is that Google gave very clear guidance as to what they believed good starting values between those were. So like in a very simple red, amber, green context, this is where your site would fall. And at that point, I think it's important to talk about metrics, right? Because you may have heard the adage, you are what you measure. And we know this from like an agile context in terms of what your team measures, it optimizes for in terms of their workflow. And the same falls for performance, right? You will immediately try and optimize and make good on the things that are being actively measured. Now, the point behind Lighthouse is to guide developer behavior to create better web experiences. So when the metrics are leading to really good results, in scare quotes, for sites that are not necessarily good, or really poor results on sites that are doing pretty well, but are failing at one or two key metrics, it doesn't guide the right behavior. You know, people think that they're good enough, therefore they don't have to get better. So in some ways, the introduction of Web Vitals helped combat that, because what we saw was some high-scoring sites dropped, some a little bit and some significantly, and most poor-scoring sites went up just a little bit, some a lot, because they were no longer being double penalized for having a slightly slower time to interactive. Okay, so now I get to my why I abandoned the demo. So the demo that I had was very heavily JavaScript focused, obviously. And because of that, it leaned into the time to interactive and the first CPU idle. Now, with the changes, it meant that those by default worked really, really well, which is a good thing because it now reflects what your typical starter project looks like. You're not going to be heavily penalized by Lighthouse just for having a vanilla JavaScript project, right? But that also meant that showing you how to optimize that stuff wasn't necessarily meaningful. And I decided to take the opportunity to talk through some of the theory stuff instead, rather than show. So for those of you that were looking forward to some React-specific demo code, I'm really, really sorry. I can link you to a talk where that actually did work, but this is not that talk. However, there will still be Lighthouse. Okay. Now, I'm going to show a little bit of workflow of what Lighthouse looks like, just so we can start talking about some of the interesting bits and pieces. So firstly, I'm assuming that people know how to get to Chrome DevTools, which is either F12 or Command-Shift-I or Control-Shift-I or right-click inspect elements. And there'll be this pane on the right-hand side, helpfully labeled Lighthouse. Previously, it was called Audit, but now it's just called Lighthouse, which is a lot clearer for people. There are a bunch of categories which you might care about. You can check on mobile or desktop for running a Lighthouse report, and you can care about progressive web app features, best practices, accessibility, SEO, if you do. I clearly only care about performance, so only leave that one checked. And there are a growing set of community plugins that are very niche or domain specific. Like, for example, I've had to do a lot of customizing of ads, so I've got the ads plugin installed in my Chrome. Then you can just smash on this big blue button, which is generate report, and you get a Lighthouse score. Now, the Lighthouse score is made up of a bunch of components. At face value, it's really easy to consume, but it's made up of a big number that business can understand. This is a 67, not a 67% because it's not a percent of what, but it's a score of 67 out of 100. And that's something that you can share with your business people for every single change that you make. There's a section which shows the metrics that were tracked and measured that make up that score. And those are very useful to track individually. And we've discussed them in the past. There's this innocuous looking button that when you click on it, gives you this detailed flame chart that that shows all of the CPU events, all of the disk I/O, and all of the micro tasks that were queued, and which scripts they came from, and all of the rendering work that the browser did. And it's super, super cool. And one day when I'm big, I hope I'll be able to read it. But again, today is not that day. And then below that, you get the sort of film strip approach, which shows you the major rendering points of your web application. So on a typical one, you'll see a whole bunch of white blocks, and then it'll start showing bits and pieces of your application being rendered. It's not very useful in this because it's a complete client-side application. So the code is already there. Then if you scroll down a little bit, it's got two things. Firstly, it's got a set of opportunities, three things. Firstly, a set of opportunities, which are some audit feedback that might help you improve the performance of your page. Some of them will have a direct impact on your key metrics. Some of them won't. They're just useful things that might improve your overall performance. So it's not a direct correlation, but it is very interesting to dig through. And you can get stuff like, if you go through the remove unused JavaScript, it'll say where your JavaScript is where your potential savings lie. Not specifically which lines, but which files. And things like images and encoding images. The next part is a whole bunch of diagnostics. So these are very interesting meta pieces of information that are not metrics to be measured in terms of the score. And things that are useful is stuff like keep request counts low and transfer sizes small, where it'll list all of the requests that you're making and what each size of those requests were. It'll show you which domains you need to pre-connect to because you're going across domain, and it'll show you things like where your layout shifts are during page load and things like that. Very useful stuff. Finally, you might want to drill into parts because there are sometimes some false positives in there. So you might see some interesting things as to things that Lighthouse has reckoned that you're okay with, that you might know, I can do a bit better. Now, if we scroll back up to the top of the page, to the performance score section, right? These metrics are covering the whole spectrum of what the page load performance should be, but some of them are very closely related. Like, for example, first contentful paint and largest contentful paint have tight correlation. And now the thing about that is that if you're trying to fix one, you will likely have an impact on the other, okay? So you'll get a positive benefit for some of those changes. Similarly to that, not in this example, but in most examples, time to interactive and total blocking time are very closely related. So fixing problems for one will likely have a knock-on impact on the other, improving it. And then cumulative layout shift is a complete outlier because it's an introduction at trying to get layout stability on pages, but it's the only thing that isn't really, strictly speaking, load performance related. It's more UX-y, but it's interesting nonetheless. Now, with any kind of performance optimization, it's really important to know that this is a big balancing act, right? If you want to remove one part or change one part of your page, it's going to have a cascading impact through the rest of your page. And something else might become a bottleneck, or you might cause other problems elsewhere. So with this, when firstly looking at the stuff, and then secondly, implementing some of the changes, you need to remember to make small changes, or as small as possible, and then measure that at every single point in time. So having said that, let's take a look at some of the typical strategies for optimization. So if we group first contentful paint and largest contentful paint together, basically what we're trying to optimize for is when the user sees the page content. And there's a bunch of stuff that we can do for that, or there's a bunch of stuff that causes it and a bunch that we can mitigate. So this is all down to blocking the render path of the HTML parser, right? As it's trying to read through all of your markup and render your stuff. So getting everything off of that critical render path means that the browser itself can display content that you're delivering to the user quicker. Now, the first one is deferring JavaScript. which I think we're going to talk about in a little bit more detail in a moment, for trying to get JavaScript out of your critical render path. The second one, which is, easier said than done, which is speeding up the content download itself to make sure that you can access those files quickly. And as an aside, this is part of the reason why some problems you'll only realize in production and not on your local machine. Or if you're sitting in a high connectivity environment like Silicon Valley or London, you'll notice that this is less of an issue because you're close to your content and you've got good connectivity. But there are ways to pre-connect to critical content. So to start doing DNS prefetches, just using tags in the header to go and connect to cross-origin domains and make sure that you're at least starting those network connections independently of the render cycle. And then finally, if you are going to try and serve content at some point in time, if that content exists inside JavaScript or JavaScript rendering, you're going to lead down the path of server-side rendering or pre-rendering to try and take the burden of rendering off of the browser and put it on a bigger machine that's under more control, that you've got more things to tweak. Or, like my talk on Wednesday, take it out of that process entirely and do it up front. So pre-render it and just serve static files. Now, at this point, I'm just going to call out that one should be very careful of things that claim to be isomorphic or universal. So thinking of React server-side rendering and rehydration, or Angular universal, or Meteor, or anything like that that says, well, you can write code once and it'll server-side render it and then magically re-render it, because there are huge performance dragons hidden in those. But that's a talk for another day. Moving on from FCP and LCP, we get onto the JavaScript-y stuff. Okay, so time to interactive and total blocking time. Now, I feel like these two metrics, or the JavaScript rendering itself, is the fulcrum of front-end performance, particularly at the moment, because if you do this well, chances are more than likely you're going to have a high-performing website, and if you do it poorly, chances are more than likely you're going to have a poorly performed website. But overwhelmingly, what we're trying to do is we're trying to minimize the amount of time that JavaScript blocks the main thread as a part of your render cycle. And a part of that might be minimizing the main thread work, right? So doing less CPU work so that the browser window itself doesn't have to thrash with JavaScript tasks. Now, typically where we see that is by reducing inefficient tasks. And this is where your computer sciencey stuff comes in, looping over large arrays, nested in large arrays, or whatever. Or long-running tasks, things that are keeping the browser busy in terms of just doing repeated work or connecting to external resources and blocking up the network stack. And then finally, and we're definitely going to cycle back to this, is to limit unnecessary code shipped to the browser. Now, I just want to make this very, very clear. You should not be sending any code down to your user's mobile device that you do not intend to execute, okay? And we, as a community, are very wasteful with this in particular. So I'm calling this out, and I'll show you how to mitigate this a little bit. Now, I mentioned deferring JavaScript earlier. Now, deferring JavaScript, I have found a very, very effective way of getting JavaScript itself out of the render path. And it's really simple, right? You literally just have to put a defer in your script tags that link to wherever your JavaScript is. That's it. What this does is it moves the pause, compile, and execute step all the way after the render stuff and just before DOM content loaded. So it's before the user interacts with the page, and the net result is still the exact same from your JavaScript execution. And by that, I mean like the order in which you link your deferred scripts still are guaranteed. It'll execute in that order. But it just doesn't block the render while it does so, giving you the best possible chance at serving the user fresh content while you get your stuff together. Now, a lot of people refer to async as well, and recommend that you use async instead. Now, there's an interesting trade-off here. because what async does is it starts downloading the script in the background, the same as defer, but as soon as it's done, it pauses the render thread and then executes immediately, blocking render for that period of time. And additional to that, when you use async, it doesn't necessarily guarantee execution order. So the order in which you link to your script tags is not the order in which they will execute, depending on which one's bigger, which one's faster. And these are all problems. Now, there are use cases behind which when you do want to use async. So when you have to get a script to execute as early as possible without it being blocking, you can use async. But barring that, I have found that you get better results by just ignoring it and going straight for defer. So just to reiterate and to maybe just explain it visually with them all on a single chart. So when we just link to a script tag, a JavaScript tag normally, what will happen is that we'll render until the browser gets to where that script tag is. Then it'll stop everything. It'll download that script tag. It'll pause and compile that script tag at runtime. Then it'll execute it, and then it'll carry on rendering. So that takes a long time. Your user's waiting with like a blank screen until that. And what we used to do in the old days is we would then put the script tag at the bottom of the body, and that's really a hack, right? That has always been a hack, and we knew that. Now, async is the first one. So as we said, like it will download in parallel. So as soon as the browser renders and gets to where that script tag is, it'll say, oh, cool, I've got an async script tag. I'm going to start downloading it so long. Then it'll keep rendering. And when it's done downloading it, it'll stop everything, pause and compile, and then carry on rendering. And then for the deferred script, it's going to download it in the background, carry on rendering the whole page, and only pause and compile and execute just before DOM content loaded. Now, DOM content loaded, importantly, is a lifecycle event that shows that the DOM and the JS DOM and the CSS DOM are, sorry, CSS I think. How do you say that? Are all loaded up and primed and ready to go, but the stuff that's non-critical resource, so things like images and iframes and videos and that kind of thing, those are not necessarily there yet. Those only get fired on the loaded event. So basically think about that as the important executable code event for your browser page. Now, that's the first thing that you can do, but that's not nearly enough. So we're going to spend some time going over how you limit unnecessary JavaScript code. So the first thing that you can do is you can lazy load code that's not essential for the render. Hopefully you'll remove unused code and not try and rely on your bundler to do that for you. And then maybe look at using alternatives, so built-in browser functions, if you can, or smaller dependencies. So if you go into lazy loading, now this one's actually super easy, right? So if you look at the top line, which is import component from component, that's what's known as a static import, and really important for modules and for tooling, so it can figure out what your dependency graph looks like and what it can, quote unquote, tree shake. Now, when you use import as a function, and it is a promise function, or it returns a promise, that's your dynamic import. And that's also very useful for your tooling, because that is a key indicator that whatever sits on the other side of that can be split into a completely separate code bundle and linked into the page completely separately. Now, by and large, bundlers, all of the popular bundlers will do this for you, but it's really not that difficult to accomplish just by hand, right? The only thing that I want to call out, and this was the bulk of the demo that unfortunately we're losing, which is the fact that there are framework-specific idiosyncrasies. Because for this to work, you need to download and parse and execute code, and then in a React context, you need to hydrate that particular bit. So React.lazy and React suspense do this thing for you in a React world. So I can recommend that if you are interested to go take a look at those things. The next thing you can do is ship modern code, right? We shouldn't be loading ES5 standard code that's like a decade old, just because one browser out of all of the browsers that we have to support uses it. use the modern language features. And to do that is really, really easy. So there is this, if you use script type module, obviously that's going to load everything with ES modules. And if you want to still support old module browsers, like IE11, it won't recognize script type module. So you can link your old script and then just use a no module flag. And then the browsers that support script type module will not execute the no module, but the browsers that don't will execute the no module because they don't recognize no module either. And the nice thing is that by and large, your transpiler will do all of the heavy lifting for you here. And there's a nice opportunity for you to, for example, use your tooling to bundle just the polyfills that you need for the code that you've written. And if you use browser targets and Babel preset, you can basically say, well, these are the browsers that I want to support. This is the usages within my code base, and CommonJS will, CommonJS. Words fail me. But it'll basically work out what it needs to bundle at runtime. Now, finding unused code is actually really, really hard. So as much as I shouted at you earlier, it is not a trivial thing. Now, there is a couple ways you could do it. So there's Chrome code coverage, which is hidden in a little radio menu in the console that you can go and you can run code coverage on a page, and it'll show you which lines are unexecuted when it reloads the page. Now, that doesn't mean that it's unused, because there might be circumstances that that code does get used, but it's a really key indicator for stuff that is just accidentally slips into the build, right? I've worked on sites where 95% of the code that gets shipped to the browser is unused. And if you're honest and you go take a look at it, you'll find that that's, very similar when you use client-side libraries. Now, how you identify how that stuff sneaks in is by using something called Webpack Bundle Analyzer. So Webpack lets you spit out all of the statistics of how it compiled those bundles. And you can use Webpack Bundle Analyzer to build a little UI that lets you drill in and figure out, well, which are the big blocks, and the big blocks are the ones that are large sizes, and figure out which of that stuff looks like you need it. And when you identify a dependency of yours, like Moment.js, for example's sake, or you want to try and find a dependency that's safe to use, I strongly recommend using a service called Bundlephobia. I use this whenever we add a dependency, where you can just on Bundlephobia search for the bundle as it is in npm, and it'll tell you what its size will be and how much approximate time it'll add to your build in terms of downloading, parsing, and compiling. And then finally, we're going to talk briefly about monitoring. Now, the nice thing about Lighthouse is that there are lots of options for automating it. You can run it on the CLI, you can run it yourself by hand and just keep track of the scores, download reports, but there are lots of built-in tools. So web.dev/measure, if you go and sign in for an account, you can say, well, this is the URL of my domain for your whatever your personal site is or whatever you want to track. And it will keep track of that over time and suggest improvements and measure you against yourself, but it's really limited. Now, the Lighthouse team themselves have built something called Lighthouse Ci, which you can integrate straight into GitHub, which will run a whole Lighthouse audit on your code stack on every commit as a part of your continuous integration process. And it'll potentially even fail builds when you drop below specific thresholds. And it'll keep track of your performance over time, which is great. I haven't used it myself, but it's earmarked for future use. And then additionally, there are other things that are third-party products. Now, the thing that I do use is something called SpeedCurve, which uses Lighthouse under the hood, and it provides real-time production monitoring that we basically keep track of several runs on several locations and different browser devices and networking conditions globally, which is really cool if you care about sort of a global footprint of stuff. I'm a bit of a fanboy in SpeedCurve, but I'm trying to tone it down. And then with this stuff, you can look at creating a performance budget for yourself. Now, less about the theory of performance budget and far more about the practical of performance budget. Lighthouse Ci lets you as a part of your code base, have what your constraints are, where you want your individual metrics to dip between, and what you want your bundle sizes to be. And you can specify that, and that clues in Lighthouse Ci and a build to pass or fail your build on the performance scoring. There are, if you don't want to or can't set up Lighthouse Ci or Speed Curve, which does the same, you can use Webpack performance budgets that probably come with whichever front-end framework that you're using. Their built-in CLI has it. But basically, it just caters, like, they're only global settings. So it's not very granular, and it's not very useful in real-world scenarios. And for that, I recommend a tiny little utility called bundle size. And bundle size lets you, for every single one of your output files, CSS, JavaScript, whatever, specify how big that file is. Now, I know that sounds like a pain because you have to update it every single time you make changes, but that's what you want, right? On every single pull request, you want to say, well, I'm deliberately and knowingly increasing the bundle size here rather than accidentally including a megabyte of JavaScript. Okay. So on that point, I'm going to really quickly conclude before I take some questions. So what I call you to do is to understand the key events of your browser. So what is going on? Understand the tooling, your ecosystem, the stuff that's built into the browser that you're probably using right now. And then to really apply Occam's razor and cut away as much stuff from the critical path, even when you're doing well. Make sure that you keep that clean because it ensures that you won't regress. When you're trying to make changes with the stuff, it's really easy to get lost and not be sure about what had what impact or where you really are and regress. So make really, really small measurable changes and then keep track of that over time. And then finally, automate as much as possible, monitor as much as possible, and keep track of your history. And don't ship code you're not going to use in the browser, please. Thank you very much. I'll take whatever questions you have.
Hey.
Hey, Mike, awesome presentation.
That last point came off like really, don't ship code. Yeah, it came off with some power. We do have a few questions, however. From Clarisse, she's asking if you have ever tried Lighthouse Metrics. I think it's lighthousemetrics.com. Yeah, lighthouse-metrics.com, where from what they say, the website, they use Lighthouse behind the scenes, but they also give you like your ratings, your scores over different centers, different regions rather.
So I haven't used that. That looks very similar to Speed Curve, and that's exactly what we use Speed Curve for. So I mean, it looks like a good tool. I've never looked at it. But I think using something like that is a really, really good idea.
All right. I'm guessing that it's I'm not sure. I did not check the website either, but yeah, it's got paid alternatives, so like paid subscriptions as well for different features. Yeah, it's an interesting thing to check out. I just opened the site. I'm guessing you did too.
Yeah.
All right. There's a second question. This one is interesting. When you use Lighthouse, you get the score per page. So is there a way to make sure, like, for Lighthouse to crawl through the pages, like via a sitemap or something, to go through the different pages?
There totally is. But as soon as you do that, you're out of the realm of just a single button push on this page, right? So you need some measure of automation. And that's where the Lighthouse CLI and then Lighthouse Ci itself comes in. Because with Lighthouse Ci, you can say, well, these are the pages that I care about, and this is what their bundles look like. This is what their performance characteristics should be. Because a website and the various parts of a website doesn't have one score, right? It doesn't have one load time. Different pages should do different things. I think Lighthouse the tooling in Chrome falls into the default of trying to fix problems where developers are looking at a single page, or the propensity for developers to have single page applications. But as you take a step lower, the automation tooling and the CLI and the CI and third-party tools are all designed to solve that problem.
Yeah, that makes sense. It depends on what you want to do, I guess. How you want to approach it and how you want to use the toolings you have available. So there is a comment. It's not really a question, but it would be interesting maybe to get your views on this. It's from Cedric saying that AMP is trying to solve the cumulative layout shift out of the box. Well, he thinks that AMP is trying to solve that. What do you think about that? Is that a possibility that AMP is going to tackle that issue?
So I am by no means an AMP expert, right? But AMP tries to solve a lot of problems. So it's a suite of products that are trying to push performance, which is amazing and admirable, but it's also a JavaScript library that predicates how you're going to write those pages.
Yeah.
Now, that solves that problem in terms of AMP. If you're going to write an AMP page with a specific view of creating something that can surface on the Google Search Console, right? You know, when you search for something and like it's got that ribbon at the top. But not all of our applications that our users need to access are all about accessing it via search. And in those cases, AMP doesn't really fix that per se. And yeah, so I don't think it completely fixes it.
Yeah. No, but it's like I said, it's not exactly a question. It was more something about an opinion. We do have one more question though, from Cedric himself. When you say don't ship unused code, do you include the framework's code in that statement?
Well, if your framework has large amounts of unused code in it that you're not using, then I would suggest that you take a long, hard look at your framework and what percent of your framework is unused, then maybe you've got the wrong framework. Maybe you need to pick something smaller and more targeted.
Yeah, that kind of makes sense, actually. We got, well, at least I'm guessing that we got the gist of it. We got the juicy part at the end. Taking a good long look at the framework that you're using, because if you're not using it to a full extent, it doesn't make sense. That makes sense. So let's see if we can. He said, "Thanks for that brave statement, Mike." So let's see. We have two more questions, and then we can wrap up. So you mentioned poor connectivity and feature phones. How do you test those effectively? Is that normally possible with Lighthouse, or
Definitely, to a certain extent. So I'll give you the right answer after I give you the useful answer. Okay, so the useful answer is that you can, in Chrome DevTools, throttle the network connectivity to something like slow 3G. And you can throttle the CPU usage to a specific threshold to say, well, this is the kind of CPU I would like to emulate, or the kind of tier of device I'd like to emulate, and then run your Lighthouse report against that. So it's a very good way of approximating what the performance on those devices is like. The correct answer is get yourself a bad feature phone and test on it. And it's painful. It's painful.
Yeah. Yeah, that's if you start collecting phones for different, that's a hard road trying to cover the different one. I guess get yourself one of the low end phones and limit yourself
the
to
older
2G
models, maybe.
Yeah, just try. Yeah. So with that, Mike, we are going to wrap up this session. Thank you very much again for being here for this second session. It was just as good and as inspiring. I learned something new from it. Do you have any closing notes before we finalize the session?
Just thank you very much for having me. Hopefully we'll speak again. I love speaking to you. And you must please stay safe. And good luck with your march tomorrow. Go to your march.
Hey.
Yeah.
Thanks a lot.
We are getting shout outs from Mike. All right. Well, with that, thank you for being here, Mike. I hope we'll get to see you maybe next year physically in our physical conference.
Yeah.
Till then, well, enjoy the rest of the show. It's nearly over. We are going to have a podcast and then a closing ceremony afterwards. All right. Cheers.
Thank
Bye.
you so much for your time. Bye.
All right.
Hey, we
So,
are coming to the end of a track.
so we'll see you guys then. All right.
Hang in there,
Cheers.
guys.